Hello everyone, welcome to Compiler Design video series. In our previous video, I have already discussed about source language, issues, storage, organization and static versus dynamic memory. In source language issues, there are 5 issues: procedure call, activation tree, control stack, the scope of declaration and bindings of names. Storage organization techniques, there are 3 different techniques: subdivision of runtime memory, activation records and compile time layout of local data, and static versus dynamic memory allocation. All these topics are already discussed in our previous video. In today's video, I will discuss about storage allocation strategies. There are 3 different strategies: static storage allocation, stack storage allocation and heap storage allocation. Next is parameter passing methods. According to types of parameters, there are 4 common methods are used: call by value, call by reference, copy restore and call by name. Then after, block structure and non-block structure storage allocation. Then what is symbol table, how characters or any identifiers are stored in symbol table. Next, data structure for a symbol table, and last, dynamic storage allocation techniques. These all topics are covered in these videos. Then first, what is storage allocation strategies? The different storage allocation strategies are static storage allocation, stack storage allocation and heap storage allocation. In static storage allocation, layout storage for all data objects at compile time, while in stack storage allocation, it manages the runtime storage as a stack, and in heap allocation, it allocates and deallocates storage as needed at runtime from a data area known as heap. Then static storage allocation. In static allocation, names are bound to storage location. So if your memory is created at compile time, then the memory will be created in static area and it's only once. So static allocation supports the dynamic data structure. That means memory is created only at compile time and deallocated after program completion. Whenever you compiled your program, at that time memory is created, and after completion or program, the memory is deallocated. But the drawback with static storage allocation is that the size and position of data objects should be known at compile time. So you know the size of your data object at compile time, and restriction of the recursion procedure. Recursion means function called itself. In stack storage allocation, storage organization is as a stack. So activation record is pushed into the stack when activation begins and it is popped when the activation ends. You already know what is activation record and what are the different parameters for activation records? There are 7 different parameters in activation record. So activation record contains the local, so that they are bound to fresh storage in each activation record. The value of locals is deleted when the activation ends. It works on the basis of LIFO, last in first out, and this allocation supports the recursion process because stack is worked on base of LIFO, last in first out, and this allocation supports recursion process whenever your function called itself, which is supports in stack storage allocation. Next, heap storage allocation. Heap allocation is the most flexible allocation scheme because allocation and deallocation of memory can be done at any time and at any place depending upon the user's requirement. So heap allocation is used to allocate memory to the variables dynamically, and when the variables are no more used, then claim it back. So you can use heap allocation. So heap storage allocation supports the recursion process. In heap allocation, some data are used, then after some memories are empty. So you can get some empty blocks in between some data elements. Next is parameter passing methods. So there are two types of parameters, formal parameters and actual parameters. According to this parameter, the common parameter passing methods are used. So formal parameters, the identifier used in a method to stand for the value that is passed into the method by a caller, which is known as formal parameter, while the actual value that is passed into the method by a caller, then it's a actual parameter. For example, void sum integer a comma integer b, then after semicolon, then the parameters passed to function sum integer a and integer b are formal parameters. But whenever you call the sum method like sum 8 comma 12, then these parameters are actual parameter. So based on these parameters, there are various parameter passing methods. The common methods are call by value, call by reference, call by name and copy restore. You already studied call by value and call by reference in your C language. General example for this is swapping of data. In call by value is the simplest method of parameter passing. The actual parameters are evaluated and their real values are passed to caller procedures. The operations on formal parameters do not change the values of a parameter. In your C or C++ language, you can use parameter passing methods. Next is call by reference. This method is also called as call by address or call by location. The L value, the address of actual parameter, is passed to the call routines activation records. In call by name, this method is less popular parameter passing method because procedure is treated like macro. The procedure body is substituted for call in caller with actual parameters substituted from formals. The actual parameters can be surrounded by parentheses to preserve their integrity, and the local names of called procedure and names of calling procedure are distinct. Last one is copy restore. This method is hybrid between call by value and call by reference. This method is also known as copy in, copy out or values result. The calling procedure calculates the value of actual parameter and then copy it to activation record for the called procedure. During execution of called procedure, the actual parameter's value is not affected. If the actual parameter has its address, then return the value of formal parameter is copied to actual parameter. Here I show one example of call by value and call by reference. Just create one UDF for swapping of two number with the help of third number. First one is call by value. Here I have used one method in which I passed two parameters and written nothing. So my function is void swap integer comma integer. Because I passed two integer type values, it's not compulsory to always pass integer value. Here two arguments are passed, so values are entered in your main function. So first declare two variable, then after enter the value of x and y, display this message, then got these two values from keyboard, then call the function swap x comma y, which is entered from your console, then display the value inside the main function. X is equal to %d and y equal to %d comma x comma y. In your function definition, void swap integer x comma integer y, transfer these two variables, so I can declare third temporary variable integer t. First stored value of x in t, then store value of y in x, then store value of t into y, then after display the value of x and y. Here you can got swap values. For example, here I entered two values 8 and 12, then you can got message like this: values inside the main function, x is equal to 8 and y equal to 12, and from these values inside the swap function, x is equal to 12 and y equal to 8. In call by value, whenever your function is called, at that time value is swapped, but in main function it's not swapped, it's a actual value. While in reference you can pass its address, so in main function it is also swap the value. So in both this message you can got swapping value. In call by reference, void swap integer pointer comma integer pointer. In void main, enter two values scanf %d %d and x and y, then swap and X and Y. Here I passed address of these two values, then display in main function the value of X and Y. Then after in swap function also display the value of X and Y. In call by reference you can got in both cases the swap values. For example, here I entered values of X is equal to 8 and value of Y is equal to 12. Then output like X is equal to 12 and Y is equal to 8. Then values inside the swap function, X is equal to 12 and Y equal to 8. Both these functions you can got the swap values because it pass address. So at that address values are swapped. Next one is block structure and non-block structure storage allocation. Storage allocation can be done for two types of data variables. First is local data and second is non-local data. So the local data can be handled using activation record, whereas non-local data can be handled using scope information. The local data can be handled using activation record. What is activation record? How many parameters are passed in activation records? You already know. In local data, it can be accessed with the help of activation record. So the offset relative to base pointer of an activation record to local data variables within a record. So reference to any variable X in procedure is equal to base pointer pointing to start of procedure plus its offset of variable X from base pointer. While access to non-local names, a procedure may sometimes refer to variables which are not local to it. Such variables are called as non-local variables. For the non-local variables, there are two types of rules that can be defined: static scope rule and dynamic scope rule. In the static scope rule is also called as lexical scope. In this type, the scope is determined by examining the program text. Pascal and C are the example of static scope rules. These languages are also called as block structured language. While in dynamic scope rule, for non-block structured languages, these dynamic scope allocation rules are used. So the dynamic scope rule determines the scope of declaration of the names at runtime by considering the current activation. Lisp and Snowball are the languages which use dynamic scope rule. So how to access the non-local data? Your static scope or lexical scope, which is accessed using access link, and display, which is used by block structure language. Handling non-labeled data. If your dynamic scope, then used by non-block structure language, and it can used deep access or shallow access. Next is symbol table. What is symbol table? It's a data structure used by compiler to keep track of semantics of a variable. That means symbol table stores the information about scope and binding information about names. Symbol table entries. The items to be stored into symbol table are variable name, constant, procedure names, function names, literal constants and strings, compiler generated temporaries and labels in source language, while compiler use following types of information from symbol table: its data type, name, declaring procedure, offset in storage, if structure or record, then pointer to structure table. For any parameters, whether parameter passing is by value or reference, number and type of arguments passed to the function, and base address. Next is how to store your names or any identifiers or variables in your symbol table. So there are two types of representation: fixed length name and variable length name. In fixed length name, a fixed space for each name is allocated in symbol table. In this type of storage, if name is too small, then there is wastage of space. For example, I have four names like calculate, sum, A and B. So maximum length of name is calculate. In fixed length name, it uses this type of structure. So it's use blocks. For sum, it used 3 blocks, and remaining of blocks are wastage. If you declared any single character variable, then remaining blocks are wastage. So the name can be referred by pointer to symbol table entry. So this is the example how the fixed length name is stored in symbol table. Second is variable length name. The amount of space required by string is used to store the names. Find the length of string which is used to store in your symbol table. So the name can be stored with the help of starting index and length of each name. First one is calculate, which is start at index 0, and the length of calculate is 0 to 8. At the end of name, it includes $sign. So the total length is 0 to 9, which is 10. So starting at length 0 and total length is 10. So your next symbol is start at length 10. Next symbol is sum. So there are 3 characters, and at the end one is $sign. So total length is 4. 1, 2, 3, 4. So your next starting index is 14. Next input symbol is A, which is considered single block. Then after $sign. So start at 14 and length is 2. So your next symbol is starting at 16. Next input symbol is B. Then after end of $sign. So start at 16 and length is 2. So this is your variable length storage structure. So there is no issues of wastage of space which is available in your fixed length name. So there are two methods. Using these two methods, your names or identifiers are stored in symbol table. Next one is data structure for a symbol table. There are different data structures are used in symbol table. Here I discussed about basic 4 data structure. First one is list data structure. So the amount of space required by string is used to store the names. So the name can be stored with the help of starting index and length of each name. You already know how the singly linked list works, how the list executed for any node. It has two parts. One is information part and another is address part. In address part, it points the next element. So linear list is the simplest kind of mechanism to implement the symbol table. In this method, array is used to store name and its associated information. The pointer avail or available is maintained at the end of all store records, because at the last record you have no any address in your address part. It means it's a last record. So the list data structure are used to retrieve the information about some name. We start from beginning of array and go on searching to avail pointer. If we reach at pointer available without finding a name, then we got an error, use of undeclared name. While inserting a new name, we should ensure that it should not be already there. If it is there, then error display like multiple defined name. So the advantage of list organization is that it takes minimum amount of space. While in self-organizing list, to retrieve the information about some name, we start from beginning of array and go on searching up the available pointer. If we reach at pointer available without finding a name, then got an error message, use of undeclared name. This symbol table implementation is using linked list. So a link field is added to each record. So we search records in pointed by the link of link field. So any pointer is maintained to point the first record of symbol table. The most frequently referred names will tend to be front of the list. So time to most referred names will be the list. Next one is binary tree. Most frequently referred names will tend to be front of the list. So the time to more referred names will be the list. When the organization symbol table is used by binary tree, then node structure will be like left child and right child. So the left child field stores the address of previous symbol and right child field stores the address of next symbol. So the symbol field is used to store the name of symbols. In binary tree structure is basically a binary search tree in which the value of left is always less than the value of its parent node or root node. Similarly, the value of right node is always greater than the parent node or root node. Next is hash table. So hashing is an important technique used to search the records of symbol table. This method is superior to list organization. These all data structures you are already studied in your data structure subjects. So in hashing scheme, two tables are maintained, a hash table and symbol table. So hash table consists of k entries which is identified by 0, 1, 2 up to k minus 1. These entries are basically pointers to symbol table pointing to the name of symbol table, or using any hash function. Hash function should result in uniform distribution of names in symbols. So hash function should be such that there will be minimum number of collision. Collision is such situation where the hash function results in same location for storing the names. So collision resolution techniques like open addressing, chaining, rehashings are used. So advantages of hashing is quick search. Next is dynamic storage allocation techniques. There are two techniques used in dynamic memory allocation, which is explicit allocation and implicit allocation. In explicit allocation can be done for fixed sized and variable sized blocks. So explicit allocation for fixed size block, this is the simplest technique. In which the size of block for which memory is allocated is fixed. In this technique, a free list is used. Free list, it means it's a set of free blocks. The blocks are linked to each other in a list structure like shown in figure. The pointer which points to first block of memory is called available. The memory allocation and deallocation is using heap memory. So the explicit allocation consists of taking a block of the list, and deallocation consists of putting the block back on the list. So advantage of this technique is that there is no space overhead. While explicit allocation for variable sized block, due to frequent memory allocation and deallocation, the heap memory becomes fragmented. So the means heap may consist of some blocks that are free and some that are allocated. Here allocated blocks are indicated like this and free blocks are indicated like this. So this is the heap memory. In this figure, heap fragmented memory is shown. Next is implicit allocation. Implicit allocation is performed using user program and runtime packages. So the runtime package is required to know when the storage block is not used. So the format of storage block is block size, reference count, mark or marking pointers to block, and users data. There are two approaches used for implicit count. First one is reference count. Then what is reference count? It is nothing but a special counter used during implicit memory allocation. If any block is referred by some another block, then its reference count incremented by 1. That also means if the reference count of particular block drop down to 0, then that block is not referenced 1, so it can be deallocated. Reference counts are best used when pointers between blocks never appear in any cycle. And second one is marking techniques. This is an alternative approach to determine whether the block is in used or not. In this method, the user program is suspended temporarily and frozen pointers are used to mark the blocks that are in use. Sometimes bitmaps are also used. These pointers are then placed in the heap memory. So there is one more technique called compaction, in which all the used blocks are moved at the one end of heap memory so that all the free blocks are available in one large free blocks. So fragmented heap memory, compactions, all these concepts are you have already studied in your operating system. So here your unit number 6, runtime memory management, is over. Today we discussed storage allocation strategies, parameter passing methods, block structure and non-block structure storage allocation, symbol table, how name or characters or identifiers are stored in a symbol table, data structure for a symbol table, and dynamic storage allocation techniques. Thank you.